Sir has done MD and LLB and is currently working as associate professor at LN Medical College, Bhopal, Madhya Pradesh, and is director at BTTBC, Bhopal, India. And he's received the Best Poster Award at Aspire 2016 at Jakarta and Best Oral Paper Award at IFS Jodhpur. He has been representing India at ISHRE, ASRM and Aspire since 2011. I welcome you, sir. Over to you.
Thank you again. Thanks to the whole S committee for inviting me. And now we'll be proceeding. Alpesh, you had given a very good information. Till more discussion, we needed a more time, but frankly, we did not have that much time, statement and all. And so now moving to the next, I'm audible? Yeah, so now moving to the next topic. So I'll request Antonio to continue as he's a guest speaker for us. He has been doing last 30 years. He doesn't need any introduction, but in short, I'll tell that. And he's certified senior embryologist from the ISHRE. He's a lab director since 1996, and he has done the geriatrics since 1997, and is a co-founder of Repro 5 Infertility Clinic, Madrid, since 15 years, 2005, and he has done a lot of work on PGT and biopsy specialist, and he has been the collaborating professor in the Madrid, and the international experience last 30 years, and he's a member of European Technical Applications System. So now the platform is open. Antonio, you can continue your talk.
Hi, good afternoon, everyone. Can you see my presentation?
Yes.
Is everything okay?
Yeah.
Okay, thank you very much for the introduction. Thank you everyone for attending this talk, and thank you to the organizers for inviting me to be there today on behalf of Fujifilm Irvine Scientific. It's been said already, but my name is Antonio Alcaide Raya, and I am a technical application scientist at Irvine Scientific Division. And my topic today, the topic of my talk today is quality control issues in handling culture media. I think we would all agree that culture media plays a central role in every assisted reproductive treatment. It doesn't matter whether it is an insemination or an IVF or an ICSI cycle. Culture media is always in the center. And therefore, talking about culture media and quality control make total sense. From my point of view, there are two main actors regarding culture media and its quality control. One is the manufacturer, and the other are the users, embryologists mostly. The manufacturer is in charge of innovation, is in charge of quality, at least in origin, and is also in charge of providing us, the users, the embryologists, with appropriate use guidelines, so we know which media we are using, what it is intended for, and how to handle it in the better way to preserve all its properties from the time we get it to the time we use it. And on our side, the side of the users, the embryologists, our first responsibility is doing the best choice. We are the ones who know our expectations. We know our modus operandi, our protocols. We know our resources. So we have to go out to the markets and decide which media fits better our goals, which is going to be the best option for us to get the better results we want. And the second responsibility is, of course, performing our best practice, being meticulous, being careful, and paying attention to every single detail. As we are seeing today in these talks, everything matters. So we have to be very conscious, very meticulous. Of course we are, I know. And well, any media that Fujifilm produces and provides and releases goes along with a certificate of analysis in which the checkpoints of the different tests that the media has gone through before being released are collected. Not all of those checkpoints are collected, but most of them are the most important. And today I'm going to focus just on 4 of them for the sake of time and simplicity. And I'm going to focus on these 4 aspects because I think they are very important, but also because these are the aspects in which we as embryologists can act, can have some intervention. Regarding storage, this is the first step. When we get the media, we need to store it properly so the media doesn't lose any of its properties from the time we get it to the time we use it. There are 2 aspects that we have to take into account. One is light exposure, and the other is temperature. Light is a source of energy, and as that, it causes, it provokes changes, physical and chemical changes in different compounds, some of them in the media we are using. This is an example with oil, but it could happen, it could be the same for any other media. Light causes photooxidation, and that provokes the release in the media of peroxides that are deleterious for the culture, for the embryo development. Light also causes in media that has protein sources, the denaturation, deamination of proteins or amino acids, and that leads to the release in the media of ammonium ions that can be also deleterious for embryos. So light is to be avoided when storing any culture media that we receive. Temperature is another issue. The general advice is to keep every single media between 2 and 8 degrees. We should avoid too low temperatures because if we go beyond the freezing point or around the freezing point, we can alter the composition of the solution that we are dealing with, and the osmolality might change, and that obliges us to discard any media. Any media that has been frozen should be discarded, so we have to avoid freezing. Too high temperatures are also bad. We should avoid them. And high temperatures is not 50 degrees. It's room temperature for several hours or several days. So if we know that the cold change has been broken somewhere, we need to discard the media because high temperatures for prolonged periods of time can cause, again, deamination, the denaturation of proteins or amino acids. It can affect hydrocarbons. And if it's prolonged in time, it can cause some evaporation even, and that affects osmolality again. So we have to discard that media. The only exception here is some mineral oils that can be kept at room temperature, because oil is quite stable at temperature. So if, as far as we keep it away from lights, we can store it at room temperature. If we don't have any dark place, we can keep it in the fridge, but we might see some cloudiness in the mineral oil that usually it's reversible, so we can use it. Regarding sterility, I'm not going to go very deep into this. We don't have that much time. I think everyone working with cell cultures is aware that contamination is a major risk that should be avoided, is a must, because it can ruin your culture, it kills your cells. So we know how to deal with it. I'm not going to insist. We wear special dressings, we disinfect surfaces, we wash our hands like 100 times. So the major risk is losing our hands, that they won't grow back again, more than the contamination problem. So sterility is something to take into consideration, of course. Regarding pH, this is a major concern when we are talking about culture media. We can differentiate 2 locations for pH. External pH, the one in the media surrounding the cells, and internal pH, the one inside the proper cells that we are culturing. We can't act directly on internal pH. We have to do it via external pH. That means that if external pH varies a lot, the fluctuations are very frequent and very wide, we can affect pH enormously. Every cell has a mechanism to auto-regulate internal pH regarding the external value. But these mechanisms are really energy consuming, and they stress the metabolism of the embryos, of the cells, to a a very high point. They stress them a lot, and it affects the function of the cells. We deal with different kind of cells, sperms, oocytes, early embryos. Each type of this sample is affected in one way. But it is to remark here that oocytes are especially sensitive to pH because all these mechanisms for autoregulation are frozen in oocytes during the maturation and rest period. So when we deal with the new oocytes, which is really frequent in our job, in our daily job, we have to think that we are dealing with cells that are exposed directly to any external pH change. So we need to be very careful, especially with oocytes, when we work outside the incubator, not to make the media to fluctuate a lot and affect the oocytes dramatically. Also, the metabolic stress can cause, joining with the previous talk from Dr. Alpes, very interesting, by the way, this metabolic stress can lead the cell to make errors when they are going through mitotic divisions, and that can lead to an increase in the number of aneuploidies. So not stressing the oocytes and the embryos is a very important matter for us in our job to keep the quality of our job. Which factors are controlling pH in culture media? There are mainly two: buffers on one side and temperature on the other side. Both of them goes together, of course. We have different type of buffers. We can use them at different concentrations, and the types we use normally in our labs is on one side CO2 dependent and other buffers CO2 independent or switterionic compounds. CO2 dependent buffers are those called natural buffers, like sodium bicarbonate. They are controlled, the pH with these buffers is controlled via CO2. And of those that are independent from CO2, we can't do anything with them because we don't have a CO2 something to control the pH. So we have to decide which media to get in order to what we need. And these media, the most common buffers for us is HIPPIs and MOBs, both used at a concentration of around 20-21 millimolar. These buffers are there's been some concern about these buffers because they can be toxic. So they are not toxic at 20 millimolar, but to reduce the possibility of toxicity, we can use a mixture of both buffers. We can choose a media with a mixture that reduces the concentration to half of this buffer, but it also gives us the possibility of having a wider range of safe temperature at which we can work, because HIPPIs behaves very well at, let me check the laser pointer here. HIPPIs works very well at 37 degrees, but doesn't work that well at room temperature, and MOPs do the opposite. So when we mix them, we obtain almost a flat line. So we obtain a total control of pH in a wide range of temperature. So this is interesting to keep the quality of the culture that we are providing to the oocytes, especially, as I said before. And which is the range of pH that we should be looking for? The physiological pH is between 7.2 and 7.4, but for embryo culture, the ideal range is 7.25 to 7.36. That makes 7.3 the center of the target. And how do we get this 7.3? If we are dealing with natural buffers, those who worked with CO2, those that are CO2 dependent, like sodium bicarbonate, we can adjust that with CO2 levels. But the factor that controls pH is not the percentage of CO2, but the partial pressure of CO2. So we need to be aware that if we are at sea level, the partial pressure of CO2 is higher than if we are at 1,000 or 2,000 meters over sea level. So we need to adjust CO2. We will need more CO2 percentage at 2,000 meters than we need at sea level. this is important. Also, ambient pressure affects these. So the best way to achieve the correct pH is measuring the pH with an accurate pH meter. And regarding that, adjust CO2, not the opposite. If we are dealing with media that we are going to use outside the incubator, as I said, we can't do many things because they are as it comes. So here we have to do the best choice. We have to choose the one that gives us the wider range to work more calm, to work more efficiency, and that indirectly will give quality to our work. And of course, we need to avoid making the media to suffer. Is what engineers call material fatigue. If we take the media out of the fridge 10 times a day because we prepare every single media, take every single dish, for example, taking the bottle and then put it back, we are changing the temperature of the bottle continuously. We are changing we are exposing it to the ambient atmosphere continuously, and we are pushing the media and we are exhausting the media before we have used it. So we need to avoid this. We need to avoid to fatigue the media. So keep it stable as much as possible. And that is protect the bottle and work fast. Regarding osmolality, which is an indicator of whether our cells are balanced with the surrounding media and chemically and physically balanced with the surrounding media, deviations in osmolality can cause cell volume changes. And this is also very stressful for cells because they can regulate that volume change. They can export ions, import ions, export water, import water, but that mechanisms are energy consuming as well. So that will stress the cells and will lead again to cell misfunction, problems with mitosis, for example, or even cell death. So deviation of osmolality are to be avoided at all. And what affects this osmolality and what modifies this osmolality? Drops volume, has a role here. Oil layer, humidity, those aspects are all related to evaporation and affect the osmolality dramatically. So we have seen that to storage, to keep the quality of the media, the quality as they come with, we need to avoid light. We need to avoid contamination, of course. We need to avoid evaporation, and we need to control the temperature and the exposure to ambient atmosphere that we expose the media to. So all of us know this for sure, but just to remind, we have to keep the bottle slightly closed in the fridge. It's advisable to calculate the volume that we need in one day, so we can pipette in one go. We take the bottle just once, pipette all the volume we need, and distribute from that second tube to all the other dishes and tubes that we are going to prepare. And we have put back the bottle in the fridge. So we took it out and had it out of the fridge for as short time as possible. When we take the bottle from the fridge, we can tilt it gently, not very roughly, because that causes foam to happen. But we tilt it gently, and then we recover any evaporation drops that could have been could have appeared in the inside of the bottle. We shouldn't prepare many dishes and tubes at the same time. This has been said this morning when talking about ICSI. And preparation of media and tubes should be done at room temperature. And if the surfaces where we are working are cold, better. The drops, if we culture in micro drops, the volume of the drops shouldn't be lower than 50 microliters, because lower volumes exposed to the surface, to the air, to the oil first, but to the air later, a bigger surface, larger surface of media to exchange water with the exterior. So the little the drop, the more exchange we have and we have to reduce that exchange. So the more volume, the less surface, the less exchange, the less evaporation. So the less increase in osmolality. So these little things are important and are to be taken into consideration. Equilibration of the dishes. If we do the culture, the embryo culture in dry incubators, if possible, we shouldn't equilibrate the media overnight in those incubators. We should do that in a humidified incubator, so we will save 1 day of suffering to the media. We will be humidifying the media for 1 more day before placing the media with the oocytes in the dry incubator. If we are using a humidified incubator, then this consideration doesn't apply really. And of course, we need to cover any culture with an oil layer that goes from 3 to 5 mL or even more, depending on the dish we are using. So regarding temperature, we said we keep it between 2 and 8, and we should avoid repeated exposure to fluctuations. And this diagram here is the resume of what I've said so far. Keep everything in the fridge, take the bottle just once, use another tube to deliver from there to the tubes and plates to prepare, and use 50 microliters drops at least if we are doing micro drops culture, and use humidified incubators for equilibration. So just to finish, I'm about to finish. I see that I only have 1 minute left. We all know that culture media is in the center, is the core of everything. And we are really always very worried about culture media, and we want to keep the quality of culture media as it came. But if we focus just on culture media, we won't succeed. We need to attend to all the other factors around culture media. We need to attend to incubator, air, oil, gases, embryologists ourselves, as it's been said this morning also, because everything counts. Everything is connected, and everything is part of a system. And if we want to get the best quality, we want to keep the quality of the media, and if we want to keep the quality of our job, we have to take everything into consideration, not just focus on culture media, of course. And just, this is the last one, and I love this sentence. It's from the Cairo Consensus Guidelines, published in 2020, saying that there is only one thing that is truly important in an IVF laboratory: everything. This is what I said before. We need to pay attention to every single detail. Every single detail counts. Maybe the best embryos, they need almost anything. They can go farther with anything. But if we are in the limits, as we usually are, then we need to pay attention to everything. And that's all. Thank you very much to everybody.
Thanks, Antonio. It was a very nice and informative. And now it is open for the questions. So I think anybody who's interested, any doubts, because we have explained a lot in detail. But before anybody asks, one question for me is that just you have summarized in very good form that it is the air quality, the duration of the handling of the outside the incubator, and the embryologist how much is trained. So considering nowadays we are single step versus the sequential media, I think in my experiences and all that, single step media has got less chances of insult and all. But you are the more experienced, so can please highlight?
Yeah, sorry, you said that the continuous cultural media had more?
It has better, it will have a less risk of insult of the air and all, because the media has to be handled properly. So the single step media needs a little less intervention, so there will be chances of less insult and the proper media requirement as per the guidelines of the manufacturer.
But you mean regarding volume or?
Everything, volume, then the repeated thing of the how you are handling it. Just a difference between the single step and sequential, which you consider better?
Oh, well, single media, sequential media, they worked very well. They adapted to every single step of the embryo, but they required a lot of work in the lab. They needed the embryos to be taken out several times. So I think that's been overcome by the continuous media, and I think that is one of the best things that we could have done with the embryos, because taking them out of the incubator stresses the embryos and stresses the media. So that's a big step forward, in my opinion. I think continuous culture media is better than single culture media, even though I don't think there are really accurate papers saying one thing or another. You can find both opinions. Whatever works better in your hands is your best choice, of course. But I think single culture, single media offers more advantages than continuous culture media. And especially we are using the time lapse, we need a continuous culture media to take the best from that. Otherwise, we won't be taking the best of a time lapse. So yeah, I think now my advice would be to use continuous, but everyone knows what is better for them. And I know labs using sequential, and they are really happy with that.
Yeah, that means the take home message, you experience of 30 years, you prefer single step, because it has to be the sequential media, the embryologist has to take up more time and all. So even if how much expert you are, if you have got less option of handling the embryos outside the incubator, that is better. But now I think anybody else, now the question is open for the platform.
Yeah, it reduces manipulation and risks also.
Yeah, both.
Dr. Randhir, there are questions in chat box. Can you please check?
Okay, chat box. Yeah, just a minute. Yeah. I'm unable. Wait, can you ask? Because
so there is one question: how to maintain the osmolality?
Sorry, there's a question of
how to maintain the osmolality.
How to maintain the osmolality?
Yeah.
Well, I think the main issue to maintain osmolality is avoid evaporation. And in order to do that, I think we have to work fast. We have to keep the media in cold conditions as long as possible. We shouldn't do the preparation of dishes in heat surfaces. There is controversy regarding the use of the flow of the cabin, whether it should be on or off. As far as I've read, and in my experience, there is no difference if you work fast and in cold surfaces. And then I would say that humidifying the culture before culturing is good. So if you have a dry incubator, which is going for sure to increase the osmolality, do the equilibration in a humidified incubator. You will save 1 day, and that makes a difference, really. And these little details are the difference at the end. So yeah, osmolality is straight related to evaporation.
And there is one more
Another question, Antonio, is that how frequently we need to check the pH?
Yeah, right.
Ideally, every lot of media that you receive should be checked for pH. They won't change a lot, but that is the ideal. But I don't think no one do that. At least in my experience, I haven't done it like that. Never. That is the ideal. But going down from there as often as you can. So if you can measure once a month or twice or one every 2 months, for example, that could be good. The more you measure, the more accurate your culture is going to be. So yeah, the ideal is a very top level, but between that and not measuring the pH at all, which also happens, there is a wide range of dates and opportunities to measure. So once a month could be okay.
Another question, Antonio, is that can we aliquot the media vials in separate tubes in refrigerator and use them as per cases? Because in India we have got batches, so we use one. We open one vial and we can have a share with the 2-3 patients. So can we aliquot in media? That's one question from the.
Well, aliquotation is something that many laboratories do. I think it's a good resource if you are used to it and you do it properly. And of course, always based on your results, you can do that. You can aliquots. If you are aliquoting, just take care of the day of aliquotation, take care of heating surfaces and everything. So I would advise to keep the tubes that you are going to put the media in the fridge, and you take them out of the fridge at the same time of the media. You put it the day before, and then you bring them out, and then you do the aliquotations like that. So you won't have any evaporation doing that. And if aliquotation is a resource for many clinics, as it is, I don't see the problem in doing it. It could not be done, but if it's done and it works for the laboratory, I think it's a perfect practice.
How many days we can, after allocating, how many days we can put in the fridge so that do you have any experience that few days, 1 week, 2 weeks, how long is it better?
You mean after aliquotation?
Yeah.
Well, I would say that you have to, well, of course, you have to respect the expiration date of the lots, and you have to respect the expiration date once opened, which is, let's say, 4 weeks. So you aliquot everything one day, you keep it in the fridge for as long as 4 weeks, no more than that. And you start using every tube, and that way the last tube is going to be in the fridge and opened for 4 weeks, which is what the manufacturer says. So you are within the range.
Okay.
I don't know if that was your question or.
Yeah. But in India, as I do, we don't keep it for that expiry date. I think Indian might.
I can't hear now.
That we use. What your experience? I think in your countries, you don't use allocation. If you're using, how long shall
Sir,
we?
sorry to interrupt. We are running out of time, sir.
Okay. Yeah. Thank you. So I think thanks, Anthony. The next we can have that. So I thank again the ACE for inviting us and giving it. Thanks, Anthony.
Thanks to everybody. Thanks to you. Thank you very much.
Thank you so much.
Yeah. Thank you, Dr. Antonio, and thank you, Randeep, sir.